So this pencast is a review of the commutative and associative properties of addition and multiplication. So let's start with the commutative property of addition. Remember that the word commutative sounds a lot like commute. So when you think about commuting from home to school, you think about going from one place to another, or moving. You actually have to physically move from one place to the other. And that's what the commutative property of addition says about addition. It says that we can take something like 3 plus 4, and it will have the same answer as 4 plus 3. So notice that in the first one, the 3 is the first number to occur, and in the second one, it's moved. The 4 is the first one to occur. So these two numbers can change places in the expression, and you get the same answer. And it doesn't matter how many numbers we do this with. So we could have something like 5 plus 11 plus 17, and the commutative property says I can rewrite this as 11 plus 5 plus 17. I can move them around any way I want. I could rewrite this also as 17 plus 11 plus 5. It doesn't matter what the order of the numbers is, so I can actually physically move them around in the expression. That's the commutative property of addition. The commutative property of multiplication says the same thing about multiplication. So basically 4 times 5 is going to equal the same thing as 5 times 4. I can change their position. Here the 4 is in the first position and the 5 is in the second position. In the second expression, the 5 is in the first position and the 4 is in the second position. So they've changed their positions in the expression. And just like addition, it doesn't matter how many of these I have. So I could say something like 3 times 9 times 12. The commutative property of multiplication says I can rewrite this as, say, 9 times 12 times 3. I can actually physically move them. So the 3 is in the first position in my first expression, and it's in the third position in my second expression. So the commutative property of addition or multiplication just says that we can move our terms around in our expression. Now notice that there is no commutative property of subtraction or division. It won't work for subtraction or division. And that's why we often change our subtraction to addition of the opposite. So, if I had, let's go back up here under addition, if I had, say, 4x minus 5 minus 7x, and I wanted to rearrange this so that the like terms were next to one another so that I could simplify, I could take minus a positive 5 and use my subtraction rule. So I'd say minus a positive 5 is the same as adding a negative 5. And minus 7x is the same as plus negative 7x. And that allows me to use the commutative property of addition to place the like terms next to one another. So that's why we use these properties. For the commutative property of multiplication, we often use it to bring the coefficient to the front. So sometimes you'll see an expression and it'll look like this, x times 3. And in algebra, we really want this coefficient moved to the front. And the commutative property of multiplication allows us to do that. We can rewrite this as 3x. So that's the commutative property of addition and the commutative property of multiplication. And now we want to look at the associative property. The big difference is that in the commutative property, terms move. When we're looking at the associative properties, only parentheses are going to move. But the terms themselves won't move. So the associative property says that if I have something like this, the sum of 2 plus 5 in parentheses plus 7, I can move the parentheses. The order of the terms isn't going to change. I'm still going to have 2 plus 5 plus 7, but instead of the parentheses being around the 2 and the 5, I'm going to put them around the 5 and the 7. When we have parentheses around two terms, we're associating those terms. So notice that the order of the numbers is the same. So I've got 2, 5, 7 on one side and 2, 5, 7 on the other. What's changing is which of the two terms gets associated first. And this is called the associative property of addition. The associative property of multiplication says the same thing about multiplication. So if I have 3 times 9 times 4, what this associative property of multiplication allows me to do is, in the first expression here, 3 and 9 are being associated first with the parentheses. Well, I can move the parentheses and associate the 9 and the 4 first. But once again, notice that the order of the numbers didn't change. I've got 3, 9, 4 on the one side and 3, 9, 4 on the other side. So that's the associative property of multiplication. So let's go down here to examples and see if we can't figure out which property is being used. So for number 1, we've got 3 plus 4 plus 7 equals 4 plus 3 plus 7. Well, what I'm really looking for is, have any of the terms moved positions? So if I just look at the 3, that's in the first position here. But on the second side, it's in the second position. So that 3 has actually moved position in the expression. Therefore, it's commuting. Okay, so this is the commutative property. And since it's over addition, we would say that this is the commutative property of addition. In example number 2, once again, I look at the order of the numbers. 2 times 8 times 4 on the left side, and 2 times 8 times 4 again on the right side. What's moving is the position of the parentheses. So that's got to be the associative property. And since it's over multiplication, we would call this the associative property of multiplication. Moving on to number 3, once again, the first thing I'm going to look at is the order of the numbers. 3, 5, 9 on the left, 3, 5, 9 on the right. Same order, and the only difference is here the second and third term get associated first. And on the left, or on the right, we've got the first and the second being associated first. So the parentheses have moved. That's got to be the associative property again. And then it's of, and then you just look at what operation's being performed. The operation being performed is addition. So that's the associative property of addition. In our last example, number 4, look at the order of the numbers. 2, 7, 3 on the left, 3, 2, 7 on the right. So these are moving. On the left-hand side, the 2 is in the first position, and on the right-hand side, the 2 is in the second position. So this has to be the commutative property. And it's of the operation being performed. Remember, when you have something like this, where two parentheses are sitting right next to one another, the understood operation is multiplication. So this is the commutative property of multiplication.